Some AI projects may be short-term, but require high-performance computing to support. Hardware planning for projects like these is not easy at all. NCHC provides high-performance computing for short-term use. It's aimed at addressing such needs. More than that, it also eliminates cybersecurity concerns. The AGAO system can now monitor equipment logs in real time. As soon as an event happens, users will receive notifications right away. They can also ask AGAO for the knowledge they need. These features have been implemented. In the past, for such large language models, even converting files could be a challenge for us. But now, thanks to NCHC's support, not only are we able to convert files without a glitch, but we are also able to improve the overall accuracy by at least 5% to 10%. This project brought together Alcor Micro's expertise in chip design and NYCU Department of Computer Science's experience in system integration and language model development. The synergy of both made this platform a reality. Fundamental challenges in analog circuit design include the difficulty in talent incubation and the intricate design process. Luckily, we had the opportunity to work with NYCU labs. Our goal is not just to train a conversational AI assistant, but more than that, we hope to truly integrate LLMs and AI into our workflows and design processes. With NCHC's high-performance computing power and platforms, the training speed is 3 to 6 times faster compared to before. A single bare metal server at NCHC is equipped with a total of 8 GPUs. This greatly boosts the speed in model training and the quantity of parameters that can be fine-tuned. It's a very significant improvement. Using LLMs combined with RAG, we managed to provide our on-site engineers the cause and ratio of defects and instantly propose a solution. Engineers can also ask questions and find answers. This is very helpful for both production and maintenance. This time, we are able to successfully boost performance thanks to NCHC's computing power resources. This project is currently used in our LPC production line, making flexible circuit boards. FlexSim Interconnect also uses technology similar to the chip design process. Such rare defects can be included in model training to build a general-purpose model. In the future, we hope the NCHC will continue supporting such projects. In particular, if NCHC can provide some training kits for us to use, that will be excellent. We hope that through this project, we can develop a new algorithm that can transcend the barriers of traditional algorithms and harness high-performance computing power to achieve fast and accurate computation. We also hope to leverage Compel's in-house developed GPU on top of NCHC's high-performance computing platform to come up with algorithms that quickly find the best answers. By synergizing these computing power and algorithms, as well as Compel's annealers compatibilities, we can realize significant speed improvements in inverse lithography. Going forward, we'll be very happy to continue working with NCHC's H100 computing power. The focus will still be on how to apply this technology to production to overcome large area lithography challenges. In fact, we can use LLMs to design automation software and hardware. For now, based on fixed hardware structure, we first explore software designs. For example, the computation of attention or convolutional models. Then we figure out how to efficiently distribute them across our fixed hardware. As I just mentioned, an LLM was used to perform the optimized search. We also try to use some historical data to fine-tune the LLM. In fact, if we use our own machines for the training, it might take a month to train an epoch or a batch. That is, it might take an extremely long time to train. With NCHC Nano 5, the training time can actually be shortened to no more than a week. I think NCHC offers very good resources.
Due to cybersecurity concerns, many factories are not connected to the internet. They generally use the company's internal network. Under these circumstances, our product achieves excellent results without internet connection. It solves problems in real time, delivering intelligent factory capabilities desired by manufacturers. During the development cycle for this kind of products on the technical side, that high-performance computing is needed in order to carry out the required testing and validation. So, NCHC's computing power support enabled us to raise the testing efficiency and helped us greatly shorten the product R&D cycle from concept to prototype, the whole process. This collaboration with NCHC targets Southern Taiwan. It is hoped that we will have an opportunity to expand in the future to allow more of our supply chain partners to utilize the resources.
We endeavor on Endpoint AI SoC. Endpoint AI SoC is primarily for wearable devices or unmanned vehicle applications. The Taiwan industry mainly consists of small and medium-sized businesses. As such, there is a strong need for a more neutral organization to provide core computing power that allows SMBs to accelerate product development. I really appreciate what NCHC Nano 5 has provided. With NCHC's support, we can tap into IT resources without huge upfront costs. Thanks to the powerful H100, we were able to achieve 100 times faster computations, at least, if not more. So we were able to move from one product generation to the next at a very fast pace. Especially in today's world where AI is rapidly evolving, I think time to market is critical to business success. Having national support from computing power, I believe, is great beneficial not only for Upbeat, but for other companies as well. Many thanks to NCHC for the computing power support given to us. An advanced application of generative AI is Generative AI Agent. It actually requires a large amount of local computing power. Take this collaboration project for example. In our platform called AI Studio, a generative AI application platform, we try to develop its capabilities of local AI agents. So we used the multi-GPU architecture in this collaboration project. We used NCHC Nano 5 for the validation and testing of our overall architecture. When we actually tried to develop some generative AI applications, we found turning unstructured data into semi-structured data for generative AI to make better use was quite a big challenge. So we attempted to use our domain training platform to convert its unstructured traditional document-style knowledge along with our AutoML numerical data into models. For internal applications, various departments can use traditional chats or agent-based approaches to extract relevant knowledge or process data. In the era of generative AI, knowledge documents are recorded in a very different format from before. To convert them into a format that LLMs understand, you actually need generative AI capabilities to help. If a company is to invest into this, the upfront costs can be a challenge. However, if government resources are available for simple POC, it will allow business owners to assess what can be achieved and help them envision what lies ahead in the future. So we really appreciate that NCHC can provide the computing power that allow our IT engineers to easily demonstrate what we are capable of achieving and facilitate our transition into the next era of technology. The collaboration project gave me a sense of computing freedom. It felt great. In addition to text inference, we will also have some VLM researches to carry out, including some visual models. I'm optimistic toward their applications in manufacturing. They should work well too.
Generative AI is really popular now. Everyone wants to do some generative AI programming, work on algorithms, and so on. But there's a lot of know-how and infrastructure needed. Some people might have been working with ERP systems or in charge of MIS. They really need these user-friendly maintenance platforms and interfaces. This is also the pain point we want to eliminate by this project.
Thanks to NCHC's computing power support, we were able to make various progress at different points in time. For example, when we looked at GPU usage, under the conventional framework, we could only achieve 30% to 40% GPU usage. But with NCHC's computing power support, we were able to conduct many experiments which allowed us to increase our GPU utilization up to 98%. So I look forward to seeing NCHC lead Taiwan's GPU AI companies or groups into future growth together. It can connect the entire ecosystem, comprising different companies and teams to make Taiwan better. NCHC's high-performance computing power is primarily powered by 8 GPU systems with memory reaching 1.15 terabyte. It can train huge foundation models and fine-tune parameters for LoRa. It can also tune very large models at lightning speeds. We used all 8 GPUs at a single node to train a large model. We could even train a large model across multiple nodes. It was a very large-scale model, like DeepSeek Foundation model. We were able to reach such a level. I hope to be the first in Taiwan to make a breakthrough and train the frontier model as regulated by EU's AI Act. Given the resources we have in Taiwan now, we have the ability to develop an EU-approved model, a regulated cutting-edge model. We hope to deliver through the collaboration between UnieAI and KC-WIN, a solution designed to help people bring AI into everyday life and work, to overcome the challenges of finding technical documents and shorten the time it takes for knowledge transfer. UnieAI is a team that started out building generative AI frameworks. We have a powerful inference engine. With this project, we developed an all-in-one platform for deploying generative AI, making the entire deployment as simple as downloading an app from an app store. More than that, our inference engine, utilizing NCHC's computing power, achieves better performance validation. The aim was to deliver twice the inference performance for the semiconductor industry to gain greater benefits. Before this project, we generally observed that for companies to invest in AI, there is a relatively large gap in their computing power. Now, with this project, we find more companies are encouraged to use NCHC's computing power to drive their own AI transition. In the past, locally, we could only test some so-called small to medium-sized models. Now, with NCHC, for the small to medium-sized models that we could only locally do 1 layer or 2 layers of LoRa fine-tuning, we can now retain the entire model from scratch or do tuning for a few more layers. I hope that our model will perform even better. So we hope to use NCHC's H100 resources to experiment with some current large models, including some common large VLM image and text models, and then try some supported video basis. Such models might require the use of several consecutive frames. By trying these models, we'll see if we can make improvements. In the past, we used some indirect methods to do checks. Now, we can do this in a direct way to determine if these functions or steps are completed correctly. We hope to use this project to develop a computational storage architecture that can offload some of the computation tasks to SSD devices, so that SSD is no longer just for data storage, but it can also handle some of the computation tasks. With some of the computation tasks offloaded to SSD, the completed preprocess can then be passed over to the CPU and GPU for training. This can boost the overall performance of the AI device. Thanks to NCHC's computing power support, we have completed the entire reinforcement learning framework, and we have achieved very good results. Now, we can determine our own chip's position within the system and its task. Next, based on the project findings, we'll design our chip. We aim to launch a new chip sometime next year. Our special thanks to NIAR and NCHC for their support on the entire project, helping us continue to deepen our work in AI, including LLM and lightweight model research. So far, we have realized the concept of Argus MPU on an FPGA. The FPGA platform is integrated with JMemTech's exclusive PUF plus PQC technology, along with the trusted AI execution environment within the Argus MPU to provide protection. We plan to use these technologies in a more diverse range of applications. With the support from national agencies, this can help accelerate breakthroughs across the entire industry. We also look forward to close collaborations and more joint projects in the future to help shorten time to market for more products and drive smoother and quicker market entry for us.